Have you ever felt like a day just flew by? Like you blinked and suddenly it was nighttime? Well, in a tiny way, you're right. Our planet is actually spinning a little faster than it used to. This means our days are getting just a fraction of a second shorter, something you'd never notice, but it's real, measurable science. For ages, Earth was slowing down, making our days longer. But recently, something changed. On June 29, 2022, scientists recorded the shortest day ever measured, 1.59 milliseconds shorter than usual. Even the tiniest changes in our planet's spin can reveal huge stories about the forces at play. So, what's going on? Is Earth in a hurry? The answer is a mix of cosmic forces, from the moon's pull to melting glaciers. Understanding these changes helps us see Earth as a dynamic, living system. In this journey, we'll explore what a day really is, why it was getting longer, and what's causing this new speed up. We'll also see why tracking these tiny fractions of a second is crucial for technology we use every day, like GPS. So, put on your thinking caps. We're about to dive into the amazing science of our spinning planet. Let's go! Before we figure out why the day is getting shorter, let's get clear on what a day actually is. A day seems simple. The sun rises, sets, and rises again. That's a solar day, 24 hours. But from space, a day is the time it takes Earth to spin once on its axis. A sidereal day, which is about 4 minutes shorter than a solar day. Why? Because as Earth spins, it's also moving around the sun, so it has to turn a bit extra for the sun to appear in the same spot. When we say the day is getting shorter, we mean Earth's rotation is speeding up. This spin isn't perfectly steady. Forces like the moon's gravity, movements in Earth's core, and even weather can speed it up or slow it down. For most of history, we couldn't measure these tiny changes, but now with atomic clocks, so precise they wouldn't lose a second in millions of years, scientists can track Earth's rotation with incredible accuracy. These clocks have revealed that our planet is, indeed, spinning faster. Even a millisecond matters when it comes to understanding our world. So, the next time you check the time, remember, it's more complicated than it seems. Our days are shaped by cosmic and earthly forces alike, and right now, those forces are making our days just a little bit shorter. For billions of years, the moon has been the main player in Earth's changing day. Its gravity pulls on our oceans, creating tides and a bulge of water that's always a little ahead of the moon's position. This bulge tugs the moon forward, making it drift away from Earth. About 3.8 centimeters a year, the speed your fingernails grow. But this energy comes from Earth's rotation, so the moon's pull acts like a brake, gradually slowing our spin. That's why, hundreds of millions of years ago, days were much shorter, just 18 hours long. The moon's tidal braking has been lengthening our days for eons. But now, something new is happening. Forces here on Earth are starting to overpower the moon's ancient braking effect. The story of our day is no longer just about the moon, it's about a complex, changing planet. And that's what scientists are racing to understand. The cosmic slow dance continues, but the tempo is changing, and we're here to witness it. For most of Earth's history, days have been getting longer, thanks to the moon's steady pull. This tidal braking is slow but relentless, adding fractions of a second to our day every century. Fossil corals show that hundreds of millions of years ago, there were more, shorter days in a year. Earth spun faster in its youth, and the moon has been our constant companion, patiently slowing us down. It's all about the conservation of angular momentum. As Earth slows, the moon moves farther away. This cosmic give and take has shaped our day for billions of years. But now, new forces are temporarily overpowering the moon's brakes. The long-term slowdown is still there, but for now, we're speeding up. Scientists are trying to figure out why. The answer lies in the complex, interconnected systems of our planet, and it's changing the rhythm of our days. What could be powerful enough to counteract the moon's braking and speed up Earth's spin? The answer may lie deep within our planet's core. Earth isn't a solid ball, it's made of layers. At the center is a solid inner core and a swirling liquid outer core. The flow of molten metal in the outer core can change over time, sometimes dragging on the mantle, sometimes giving it a push. These changes can speed up or slow down Earth's rotation, on timescales of decades, not billions of years. Some scientists think recent changes in the core's flow have reduced its drag, letting the mantle spin a bit more freely. Studying the core is tough. We can't drill that deep, so scientists use earthquake waves and magnetic field changes to piece together the puzzle. The idea that events deep within Earth can affect the length of our day is a powerful reminder of how interconnected our planet is. The core's mysterious dance is just one part of the story, and it's helping to speed up our days, at least for now. The Earth system is full of surprises, and we're only beginning to understand them. Another force speeding up Earth's spin is happening right on the surface: melting glaciers. Think of Earth as a spinning figure skater. When a skater pulls their arms in, they spin faster. As ice melts at the poles and water moves toward the equator, Earth's mass shifts inward, just like the skater's arms. This redistribution of mass makes the planet spin a little faster. Post-glacial rebound has been happening since the last ice age, but climate change is accelerating it. The melting of glaciers is now a powerful force shortening our days. It's a direct link between climate change and the physics of our planet's rotation. For a long time, the moon's braking was stronger, but now, melting ice and shifting mass are tipping the balance. The forces of acceleration are winning, at least for now. Our planet's spin is a delicate balance of cosmic and earthly forces. And right now, that balance is shifting. Earth doesn't just spin, it wobbles too, like a slightly off-balance top. This is called the Chandler Wobble. Discovered in 1891, it's a small, irregular circle traced by the poles about 9 meters wide every 14 months. The wobble is caused by shifting ocean's atmosphere and the planet's jiggly interior. Sometimes the wobble nearly disappears, as it did from 2017 to 2020. Scientists are still figuring out why. While the Chandler Wobble doesn't directly change the length of a day, it's part of the same system of mass and momentum. The forces that cause the wobble can also nudge Earth's rotation speed, if only by tiny amounts. Understanding the wobble helps scientists fine-tune their models of Earth's motion. It's another reminder that our planet's spin is anything but simple. Everything is connected, even the smallest wobbles, and every detail matters. You might wonder, does a few milliseconds really matter? For daily life, not much, but for our high-tech world, it's critical. Our global infrastructure, communication, navigation, finance, depends on ultra-precise timekeeping. We use Coordinated Universal Time, or UTC, based on atomic clocks but kept in sync with Earth's rotation. When Earth's spin drifts from atomic time, we add a leap second to keep things aligned. But now, with Earth speeding up, we might need a negative leap second, skipping a second to let Earth catch up. That's a problem. Most computer systems aren't designed for missing seconds, only extra ones. A negative leap second could cause data errors, network outages, and digital chaos. GPS is especially sensitive. Your phone's location depends on timing accurate to the nanosecond. Even a millisecond error could throw off navigation by hundreds of meters. So tracking Earth's spin isn't just for curiosity, it's essential for keeping our world running. Milliseconds matter more than you think. The tiniest changes ripple through our technology, and that's why scientists are watching every fraction of a second. The length of our day isn't fixed, it's the result of a grand cosmic balancing act. The moon's gentle braking, the churning core, melting glaciers, and subtle wobbles all play a part. For billions of years, the moon lengthened our days. Now other forces are briefly speeding us up. This tiny change, measured in milliseconds, shows how deeply connected Earth's systems are. We live on a dynamic, vibrant world, every part linked, from the atmosphere to the core. Our quest to understand these changes is about more than science, it's about understanding our home. The next time a day feels short, remember you're riding a planet in motion, part of a cosmic story. The subtle changes in day length are whispers from Earth itself. We are a way for the cosmos to know itself, and our spinning planet is one of its most incredible creations.